Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the thrashing in operating systems. Thrashing. It is a high paging activity is called the thrashing. If a process does not have the enough pages, the page fault rate is very high. This leads to the low CPU utilization, and then operating systems thinks that it needs to increases the degree of multiprogramming, and the another process is added to the systems. Next point, when the CPU utilization is low, the OS increases the degree of multiprogramming. Next one, if the global replacement is used, then the process enter the main memory. They tend to steal the frames belonging to the other processes. Eventually, all the processes will not have enough frames, and hence the page fall rate become very high. Thus, the swapping in and swapping out of the pages only takes place. This is cause of the thrashing. Here we have the diagram. At the x-axis we have the degree of multiprogramming, and the y-axis we represent as the CPU utilizations. As per the rate the thrashing happens. Next one, to limit the thrashing, we can use the local replacement algorithms, and then to prevent the thrashing, there are two methods, namely working set strategy and the page fault uh, frequencies. First one is will be the working set strategy. It is based on the assumption of the model of locality. Second one, locality is defined as the set of pages actively used together, and then working set as the set of pages in the most recent page references is the working set window. If it is too small, it will not encompasses the entire locality. Third, next one, if it is too large, it will encompass several localities. If it is equal, it encompasses the entire program. Here we have the three conditions. First one is small, and then large, and then if it is equal. Next one, D is equal to WSSI. WSSI defined as the working set size of the particular process. That will be that maybe I, J, or K. D is the total demand of the frames, and if the here we have some condition, that is if D, that is demand of frames greater than M, then the trashing will occur. Next one is the page fault frequency scheme. If actual rate is too low, the process loses the frame. Next, if the actual rate is too high, the process gains the frame. Here we have the two conditions. If the actual rate is low, the it will loses the frames, the process will loses the frames. If it is too high, it can gains the frames. And the other issues in the page fault frequency scheme will be pre-paging, and then second one is page size, third one is TLP reach, and then input output interlock. Here we have some other issues in the page fault frequency schemes. Next one will be the other issues, that is pre-paging. First one, to reduces the large number of the page fault that occur at the process startup. Next one, pre-page all or some of the pages the process will be need before they are referenced. Third one, but if it is pre-paged pages are unused, input, output and the memory are wasted. It comes under the pre-paging. Next one will be the page size. The page size selection must be taken into the consideration, that is fragmentation, table size and input output overhead and the locality. It completely comes under the page size. Next one is the TLP range. The TLP range, that amount of memory accessible from the TLP. The TLP range is equal to TLP size and the page size. Ideally, the working set of each process is stored in the TLP, and then it increases the page size. This may leads to the increases of the fragmentation, as not at all the applications requires the larger page size. Next one will be the input output interlock. Pages must sometimes be logged into the memory. Consider the input-output pages that are used for copying a file from the device must be logged from being selected for eviction by the page replacement algorithm. Thank you.